Autophagy, the body's mechanism for cellular self-repair and renewal, is a cornerstone of healthy aging. It helps clear damaged organelles, misfolded proteins, and accumulated toxins, allowing cells to maintain function and resilience under stress. But while much attention has focused on caloric intake, fasting, and macronutrient signaling in the regulation of autophagy, there is growing recognition that micronutrients, vitamins, and minerals required in tiny but crucial amounts, play a silent yet essential role in keeping autophagic machinery functioning properly. Even subclinical vitamin deficiencies, those not severe enough to cause overt symptoms but still below optimal levels, can impair this vital process. When sustained over months or years, these marginal imbalances gradually erode the body's ability to repair itself, accelerating biological aging in subtle but compounding ways. Subclinical vitamin deficiencies are often undiagnosed because they don't cause the dramatic signs of classical deficiencies like scurvy or beriberi. Yet these low-grade insufficiencies can compromise the activity of key enzymes involved in autophagy regulation, mitochondrial maintenance, and DNA repair. For example, B vitamins, particularly B2, riboflavin, B3, niacin, B6, pyridoxine, B12, cobalamin, and folate, serve as cofactors for enzymes that manage cellular energy status, oxidative stress, and methylation pathways. Even a mild deficiency in these vitamins can reduce NAD production, inhibit AMPK activation, or impair mitochondrial respiration, all of which are upstream regulators of autophagy. Vitamin B3, in the form of niacin or nicotinamide, is especially critical. It supports the synthesis of NAD, a molecule required for the activity of sirtuins, enzymes that play a central role in longevity and autophagy regulation. SIRT1, for example, promotes autophagy by deacetylating autophagy-related proteins and suppressing inflammation. If NAD levels fall due to inadequate B3 intake, this regulatory axis falters. Even before clinical niacin deficiency manifests, low NAD impairs the cell's ability to initiate autophagy in response to stress, diminishing its adaptive capacity. This can lead to mitochondrial decay, chronic low-grade inflammation, and an increased burden of cellular waste, all hallmarks of aging. Vitamin D is another commonly insufficient nutrient that subtly undermines autophagic activity. Beyond its well-known role in calcium homeostasis, vitamin D acts as a genomic regulator, influencing the transcription of genes involved in inflammation, oxidative defense, and autophagy. In aging populations, vitamin D levels often decline due to reduced sun exposure, poor diet, and impaired skin synthesis. This deficiency has been linked to increased mTOR signaling and suppressed autophagic responses. Since mTOR is a primary inhibitor of autophagy, insufficient vitamin D can lock the cell in a pro-growth, anti-repair state, accelerating the onset of age-related dysfunctions, from sarcopenia to neurodegeneration. Antioxidant vitamins like vitamin C and E, when chronically low, also impair autophagy by allowing oxidative damage to accumulate unchecked. While a certain degree of reactive oxygen species, ROS, helps initiate autophagy, excessive and unbuffered oxidative stress, common in low antioxidant states, can actually damage lysosomes and autophagy-related proteins. Over time, this disrupts the balance between cellular cleanup and cellular damage, tipping the system toward dysfunction and senescence. Even trace mineral imbalances can be problematic. Zinc, magnesium, selenium, and iron are all cofactors for enzymes that interact with autophagic pathways. For instance, zinc is required for lysosomal function and immune modulation, both of which affect autophagic turnover. Low zinc levels, surprisingly common even in developed countries, can impair lysosomal acidification, slowing the degradation of autophagic cargo and diminishing the effectiveness of the cleanup process. Similarly, magnesium deficiency, even at marginal levels, interferes with ADP production and mitochondrial stability, adding metabolic stress that the cell may be too compromised to resolve efficiently without active autophagy. The problem is compounded by the fact that these subclinical deficiencies often cluster. Poor diet, chronic stress, medication use, alcohol, and aging itself reduce absorption and increase the need for many micronutrients. Over time, even small gaps in micronutrient sufficiency, if not identified and corrected, lead to a state of chronic metabolic underperformance. Cells that can no longer efficiently recycle waste or recover from stress become prone to dysfunction, setting the stage for inflammation, insulin resistance, cognitive decline, and other markers of biological aging. What makes subclinical deficiency particularly insidious is that it often goes unnoticed until the damage is already accumulating. Standard blood tests may not detect marginal deficits, and symptoms like fatigue, mild depression, or forgetfulness are often attributed to aging itself. Yet these symptoms may reflect an early failure of cellular maintenance systems, driven in part by a quiet but consistent lack of essential vitamins. In this sense, aging is not merely the result of time passing, but of cellular wear that exceeds cellular repair, and autophagy is a key part of the repair equation. The good news is that correcting these deficiencies doesn't require extreme interventions. A modest but well-formulated supplement protocol, focused on optimal rather than minimum nutrient intake, can restore enzymatic function and improve autophagic responsiveness. This is especially important in older adults whose nutrient needs are often higher, but whose intake and absorption are lower. Combined with dietary strategies such as intermittent fasting, low glycemic meals, or time-restricted eating, micronutrient optimization can help unlock autophagy without requiring prolonged fasting or severe caloric restriction. In conclusion, subclinical vitamin deficiencies are a hidden driver of autophagy suppression and accelerated aging. While they may not produce dramatic symptoms in the short term, their long-term impact on cellular housekeeping is profound. Ensuring optimal, not just sufficient, levels of key vitamins like B3, D, and C, as well as minerals like zinc and magnesium, is critical for sustaining autophagic activity and preventing the slow buildup of damage that defines aging. For those seeking to extend health span and preserve cellular function, micronutrient sufficiency is not a detail, it's a foundation.